So in section 8.3, it's more of the same. We're going to be factoring quadratic equations, and they're going to try to use algebra tiles, which you've used in several different chapters. And we've also had some hands-on experience using them. And if I were to factor this x squared plus 6x plus 9, it's like one of these, 6 of those, and 9 of the unit tiles. And then I'm going to place the 1x squared tile and the 9 unit tiles like so in this grid, and I believe I got some extra sheets if you want to do this with the actual physical tiles. But it'll only work out where you can either make a rectangle or a square, but only one of them you'll be able to use all the tiles. And until you can make that shape, the quadratic equation is not factored. So I'm going to advance to the next area of the notes. So in part C of the notes, I have to fill in this empty space, right? And I have essentially 6 of these things, and they would fit in like so. I think this way, and this way. And then hopefully you can tell like that would look like, if you remember the multiplying by algebra tiles, something like this on top. And, right, excuse my terrible art skills, something like that on the side. And what does that even mean, right? This would be like x plus 3 and x plus 3. And as a very astute student noticed when I was showing them this, this is exactly like the box method of multiplying, or at least very similar. So all 6 of the x tiles were used so that all the tiles are accounted for and fit in the square with sides of lengths basically x plus 3. And so I read the length and width of the square to get the fractions of the trinomial, or not the fractions, the factors, and it's going to be x plus 3 times x plus 3. And this next example, right, I can now also factor using algebra tiles. This example gives us this x squared minus 8x plus 16. So I know I'm going to need 1x squared tile, 8 negative x tiles, and 16 of the unit tiles. And so as the numbers get larger, algebra tiles becomes less practical because it takes a long time to align all the tiles. But the important point is that we're just kind of learning that we can break these apart, these standard form quadratics, using this method. So arrange the algebra tiles in the grid. We're going to place the 1x squared in the upper right, and we'll arrange the 16 unit tiles in the lower right. And now, in a moment, I'm going to advance to the next area of the slide, or the notes. All right, so here we go. We got our x squared. And I'm just going to draw this because I don't have the patience to draw like 16 little unit tiles. There you go. You get the idea. That's 16 unit tiles. And now I've got to fill in all the empty spaces. I've got an x squared. I should have 8 negative x's, and I should have 16 individual unit tiles, unit of 1. So then this should work out to where, like, we got 1, 2, 3, 4, and 1, 2, 3, 4. And this is going to be an x, a unit, a unit, a unit, a unit, x, a unit, 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 unit. And right, that translates to x plus 4 times x plus 4. Now the topic of this chapter section is perfect square trinomials. And you should remember, right, if this works out to be x minus 4 times x minus 4, and I made a mistake, it's not plus, right? These are all supposed to be red tiles. So this is actually minus 4 and minus 4, and right, these are all negatives, 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 which means these were negative, also negative. So x minus 4 times x minus 4, right? This is the trinomial, right? 3 terms. 1 term, 2 terms, 3 terms. So this here is a trinomial. And it's a perfect square, right? Because this is essentially x minus 4 squared. You're multiplying them twice. And then what else? We used all the negative x tiles, and that made the side length essentially x minus 4. So this part is like straight out of the textbook, you know, a squared plus 2ab plus b squared. In chapter 5, right, we did a section called special case polynomial multiplication. And there's also a poster on my wall, kind of on the wall next to my desk, that has, you know, a lot of this stuff already there for you as well. So technically all of this is actually review. I know you've all forgotten it, but yeah, you have done it before. And if you don't believe me, just take a look at the poster on the wall, right? I mean, it's all, for the most part, right there. So that's that. So here we go. If we're looking at this, what that means is, right, we can look at these factors. Because we're essentially trying to find what a and b are, right? And this is going to be our a squared, and this is going to be our b squared. So, you know, what's the square root of 64? Well, the square root of 64 is going to be 8, right? So this is supposed to be 8. You know, and what's the square root of 1? That's 1. So what's 2 times 1 times 8 times x? It adds up to 16x. Right, and this is essentially 8 squared there. So the factored form of that is, you know, x plus 8 times x plus 8. So you can rewrite that in a simplified version as essentially x plus 8 squared. So give me a moment to check that out, and I'll move to the next section. So here we go. Let's factor these trinomials. This one's kind of a trick in this example. There's a common factor that I can pull out in all of this. And everything here is divisible by 2y. Right, so if I divide everything by 2y, I'm going to be able to pull it on the outside of the parentheses. And then on the inside, it's going to be, well, y squared plus 12y plus, oh, and I forgot to divide by 2. It's not 12y. It's 6y plus, and then 18 divided by 2 is 9. So that's a lot more manageable. And then hopefully you can recognize, like, hey, that's the square of y times y. And hey, that's the square of 3 times 3. So, if all of this winds up being essentially like, a plus b squared, on some of these special case forms of factoring, I don't have to do all the extra work with the algebra tiles if I can recognize there's a square. But I remember some of you just didn't want to deal with these additional formulas. You can factor it the other way too. It's going to be okay. I'm just saying this is a shortcut. So this is going to be y plus 3 squared times 2y. Now let's take a look at this other example. Hopefully I can recognize, that's a square, right? That's 10z and 10z. And that's a square. That's 1 times 1. So when that's the case, I know this is going to be 10z minus 1 squared. And how do I know? If I compare this right here to basically, this prior page, right? That's these conditions right here. You've got something squared, 2 times a and b. What is 2 times 10 times 1? Negative 20, right? So for number 4 and the formula, right, it winds up being the a and the b terms minus each other squared. So I hope that's starting to make some sense. Let's take a look at some more. Right, and this section here is just like in chapter 5, only instead of multiplying together, you're trying to break them apart, right? This is like chapter 5, see the poster on the wall. This is actually review. We've already done this. Except we were taking something like this and trying to turn it into something like that. Now we're taking, that and trying to break it back down. Forwards, backwards, so to speak. So, in a perfect square trinomial, right, isn't 49q a square, right? That's 7q and 7q. What about 4? Right, that's 2p and 2p. Haha, 2p. Very little. It takes very little to amuse Mr. Minton, clearly. So, right, in this scenario, we've got, it's going to be 7 squared and q squared minus essentially 2p squared. So, when that's the case, we follow this formula, which is technically not the first time we've seen it. Right, if this is a and that's b, one of them is going to be a plus b, one of them is going to be a minus b, so this is going to be 7 plus q, or I should say, not q, my bad, 7q plus 2p times 7q minus 2p. And there you go. So these are the factors. And I don't know why, but the book has us write them down again. So let's take a look at some examples on this special case as well, which, right, keep in mind, this is not the first time we've seen any of this stuff. In theory, this is from chapter, I want to say 5.3. So if you're looking at this and going, holy moly, I can't do this. Hey, maybe go back and look at those notes from 5.3 and you'll see it's just the other direction. And you'll recall that you've done it before. So this is difference of squares, right? This is an x, that's an x. This is 12, that's 12. I know when this condition happens, it's going to be a minus b times a plus b. If this is my a, this is my b, right? We're talking about x minus 12 times x plus 12. Done. 81, this is going to be 9y squared, 9y squared, 3y, 3y, a and b, right? We're going to follow this format. So this is going to be 9y squared minus 3y times 9y squared plus 3y. And that's it. You're done. Now you could probably take this one step further in the factoring, at least on number 7. But that definitely is the difference of squares. You could factor out a 3y, right? If I pull a 3y out of this one, I'm going to get I'm going to get 3y minus 1, and I could also pull a 3y out of that one, and you'd get 3y plus 1. And this will simplify to 9y squared times 3y minus 1, 3y plus 1. So this would be as simplified as far as you could take it. But this right here, also difference, look at that terrible handwriting, difference of squares. My defense, this iPad's kind of tiny.